A great circle is a circle on a sphere that's the largest circle that you could draw on the sphere, and it contains the center of the sphere as its center. The equator is an example of a great circle on the Earth. It contains the Earth's center as its center, and it's the biggest possible circle that you could form on the Earth. It has a radius of 3,960 miles. All of the circles of longitude, like the prime meridian that's shown here, also are great circles. They contain the center of the Earth as their center, and they also have radius 3,960 miles. Approximately. The Earth is not a perfect sphere, we know, but close enough. If you know that 2 points are directly north and south of each other, then they fall on a great circle. And the distance between 2 points is always the shortest if you find the great circle that contains them. So if you know that 2 points are directly north and south, you know their circle of longitude is the great circle that contains them. Suppose I wanted to fly in a hot air balloon a mile above the Earth from Timbuktu in Mali, Africa, to the Orkney Islands in the United Kingdom. Timbuktu is 3 degrees west of the prime meridian and at about 16.77 degrees north. The Orkney Islands are also 3 degrees west of the prime meridian and at about 59 degrees north. So if I wanted to fly in that hot air balloon, I could find how far I needed to go by finding the arc length from 16.77 degrees north to 59 degrees north. The radius would be the radius of the Earth, 3,960 miles, plus that extra mile that I'm above the Earth. So 3,961 would be the radius of the arc that I would be traveling. So using the radius of the Earth plus that extra mile, 3,961 miles as our radius, 2 times pi times that radius gives us 24,887.7 miles would be the full circumference if we flew in a hot air balloon all around the Earth. To find the angle in between our 2 locations, we want to subtract 16.77 degrees north from 59 degrees north. That will give us 42.23 degrees. That angle will then help us find the ratio of the circumference that we're trying to travel. So 42.23 degrees divided by 360 degrees gives me 0.1173, or 11.73% of the circumference. Remember, we're a mile above the Earth, so the circumference that we're traveling along is 24,887.7 miles. We need to travel 11.73% of that distance to get from Timbuktu to the Orkney Islands in our hot air balloon. As mentioned before, the circumference of the Earth is approximately 24,881 miles. So 11.73% of that length will be equivalent to multiplying 0.1173 by 24,881, and that will give us 2,918.54 miles. Then finding what 11.73% of 24,870.7, we multiply 0.1173 by 24,887.7 miles, giving us a distance of 2,919.3 miles. So once again, we could just use the radius of the Earth plus that extra mile for the radius of our circle, and we could easily find the angle between our 2 locations because they fell directly north and south of each other on the same longitudinal line. Our final distance would be 2,919.3 miles that we would travel in our hot air balloon, and hopefully there'd be enough room in the basket for a change of clothes because we would have quite a bit of climate change. To calculate distances on great circles that are not longitude lines or latitude lines, that is, they're, kind of go crossways around the Earth, is a little bit difficult. The angle calculations are quite complex for our introductory trigonometry class. However, we can still get the idea of arc length on our longitude circles or our latitude circles. The only great circle that's a latitude circle is the equator. So imagine that we were trying to travel from the mouth of the Amazon, which is right on the equator, to a town just south of Indonesia. So let's kind of go around the earth here, and here's Singapore. So Singapore's a little bit north of the equator. So imagine us going to some town just south of Singapore on the equator. We could fairly easily calculate how far we would have to travel because we know that the radius of this circle is 3,960 miles. Now, the mouth of the Amazon is approximately 50 degrees west. So remember, west has a negative notation. So this has a longitude of -50. And then we travel past the prime meridian across Africa to, near Singapore. And this town is at 104 degrees east. So we would have to travel an angle of 154 degrees to go from the mouth of the Amazon all the way across the globe to just south of Singapore, 154 degrees. So the angle between the mouth of the Amazon and a town just a little bit south of Singapore in Indonesia would be 154 degrees. That's because the mouth of the Amazon is at 50 degrees west, and western locations are denoted as negative. Eastern locations are denoted as positive. So if I find their difference and subtract 104 minus -50, I will actually take 104 and add 50 to get 154 degrees. But you can also just think about it. If the Amazon is 50 degrees west of the prime meridian, you have to go 50 degrees just to get to zero, just to get to the prime meridian. Then you have to go 104 more on the eastern side to get to our point in Indonesia. So now that we know the angle in between our two locations, we can find the percent of the circumference that we need to travel. Take 154 degrees and divide it by 360. That gives you the ratio or the percent of the circumference that we need to travel. We get a ratio of 0.42777 or 42.77%. So 42.77% of the circumference of the Earth is equivalent to taking our ratio 0.4277 and multiplying by 24,881 miles, giving us a whopping 10,643.5 miles that we would have to travel to go from the mouth of the Amazon to that town just a little bit south of Singapore in Indonesia. Again, the equator, which is where both of these are located in terms of latitude, is a great circle of the Earth. It's a circle that contains the center of the Earth as its center. And so we're able to just use the radius of the Earth as our radius. We don't have to go through extra calculations to find the radius of the circle because we know it's just the radius of the Earth. If locations are not on the same longitude or not on the equator, they will be on a great circle, but it's much more complicated to find the angle in between them. You can't just use their longitudes or use their latitude values like we have in these examples.